The third area I want to talk about is robotics. In the interest of time, I won't play this video, but we've always had this dream that robots can do lots of things for us. I think many in the scientific and technological community have wondered. And it is true that even today there are thousands of robots, maybe even hundreds of thousands deployed in industrial settings doing lots of very specific tasks. So specialized robots is not the issue. Like, we can get to specialization pretty quickly. But the real challenge is in generalization. How do you get the same robot to operate at a certain level of mastery on different tasks, in different environments, on new settings, with new objects, and in an interactive manner? So these are pretty challenging problem, and we're making steady progress on all of these. But again, the challenge is similar. Like, this is a problem in the physical world. So how do you collect enough data? Because when you want the robot to do a certain action, and the actions, we want them to be semantically arbitrary. So instead of saying, take this ball and put it in this net, we want to be able to say, slam dunk this ball like a basketball player would. And it should understand what that means in terms of the actual motions of the various controllers. So slam dunk to saying that I need to move this particular actuator by X degrees is a pretty big translation, and that generalization in a new environment is a pretty complex problem. But here again, the way we would do this is we would collect a small amount of data. I think by most measures, the amount of data we see on the internet versus what you can collect for robots is pretty small. You then build a good simulator, which then tries to get you to at least be effective in replicating what you did with that data. Once you know your simulator is good enough, then you can run these trajectories at large quantity, prune out the ones that don't work, and you keep doing this repeatedly. So you kind of self-play on simulation for a long time, and you get the strategies that really work. And based on these, you then understand the underlying dynamics of the system. And from the underlying dynamics of the system, you can then predict where the state of the system is going. So hopefully, like, what's emerging here is a general recipe of intelligence. And I think I want to talk about that a little bit more, even though it was somewhat implicit. So the goal really is to model the underlying dynamics or the physics of any system. Whether you're going at a game, there's some underlying dynamics that these players have mastered in their intuition. Whether it's physics, whether it's robotics, whether it's biology, there is an underlying thing that's going on that you want to model, right? And you can't do this effectively because the cardinality of the state space is really large. Like, how would you possibly play out all the scenarios when it's such a large number? So you go and systematically collect different parts of the space that you can with limited resources. You build really good simulators that you can then unroll to run lots and lots of trajectories. When you unroll these, you get the system to self-play with itself to tell you what is working and what's not, because that is often the hardest problem. To tell you whether you're getting a good reward or not is pretty challenging. So designing these reward functions is also an AI problem. Like, you throw deep learning networks at this problem to learn the rewards that you want to give at every given state. And with these reward functions, you then start really getting to get to new policies and strategies that you can then refine and optimize over time. And if you do all of these things correctly, the promise is that you will not just solve the original problem that you set out to solve, but that you will uncover new creative strategies that will take you and get you into the unknown of new solution spaces. All right. So what has all of this got to do with healthcare? This is 9 slides in, and I haven't spoken about healthcare. So I will not pretend to know the right answer, but this is a joint exploration, and so hopefully this sparks a few ideas.